Good evening, audience. Good evening, good afternoon, or good morning from wherever you're joining us. Thank you so much for being the part of this webinar series again with us as a part of PMI UAE chapter. I welcome you, all of you, to be the part of this 1.5 hour of knowledge sharing and the thought sharing session with our esteemed speaker today. Just like as the part of the series, we always going ahead with the quite a bit of nominations we are seeing a bit getting increased every webinar. So today the number has approached near about 400 kind of nominations. That itself is a kind of milestone for the PMIUA chapter. We are increasing day by day in the form of attendance, and then our focus and endeavors is definitely towards bringing you a very diversified and the vast area of knowledge sharing, just not one dimensional, but bringing you the whole ideas and the sphere of the ideas so that everybody can benefit from the project community and fraternity perspective. So again, thank you so much for being the part of this journey with all of us. We are grateful to all of you that you find the time out with your busy schedules of the family, work, friends, and then giving us this valuable time about your life and schedule to PMI UAE chapter series as well. We will be joining with more people, I think, in a couple of more minutes. So just hold on for the few couple of more minutes, and then we'll be officially launching the series session together with the speaker today. And I will be introducing myself, the team, and then the speaker and the topic as well. So just hold on for 3 more minutes, then we'll officially will launch together. Thank you. Yep. Meanwhile, please feel free to post your LinkedIn addresses, or you can start introducing yourself from the place we are joining, and that will give a good enough idea to the audience. And even might be that can help us from which field or which area of the work you belong to specifically, so that people can know that as well and can connect with you if they need to in this learning journey and collaborative journey together. Normally, we see the audience coming from different parts of the world, just not from Middle East. So we'll be happy to look forward to the audience coming from diversified regions. And that can give us a good breadth of the domains as well as geographies, and asking the right kind of informative questions that increase our knowledge and give us a scratching head to think more deeply on the different topics. So we have one more person to join and 2 more, in fact. I'm seeing 99. Oh, there we touched 100. So the century has come out together with us. So I think it's a good time for me to officially launch the session today, guys. So again, thank you so much. My name is Anshul Chaube, and I'm the part of this webinar event team. My work is to co-host the speaker and to make this journey as smooth as possible for all of us. I am being joined with the other team members, of course, Joyce, Parvez, and then Amir. We all have been working at the back to make this webinar possible and to arrange for us in this scheduled time. This webinar is specifically is the part of the series which PMIUA chapter is focusing on. And then today we have our esteemed speaker and guest, Ms. Cathy Farina, who is going to take us through the shared learning experience. Of course, she is going to present the presentation PPT and also going to talk about the experience on innovative strategies to reduce cost and boost project efficiency. In this, we will all attempt to discuss and ponder the capital projects which have seen a significant rises in the installed cost, negatively impacting the company's financial performances. To combat this, many organizations are realizing that the need of a radical shift that takes us away from the traditional execution methods to reduce this capex and to increase the project timelines in terms of efficiencies. So the conventional approaches are no longer sufficient to deliver these necessary results, and instead the industry is moving towards the more innovative strategies that challenge the traditional thinking. So that's the stage we are going to set today. on which we are going to see the knowledge, we are going to see the experience, and we are going to see the knowledge in the form of some framework strategies, which Cathy will be sharing with us. Before we go into deep dive into the session, I would like to explain some housekeeping notes. What we should expect from the webinar is that it will last around an hour and 10 minutes or 15 minutes max. We have a set agenda. We follow basically with the brief of introduction of the PMI UAE chapter. For the people and the members who have joined it first time, it will be beneficial for them to give them the background around that. Of course, we will be having a short time at the end for question and answer, where Cathy and I will try to manage best of our time to answer the questions within the time frame. Of course, we'll try to make them as in the chronological order so that the people who ask the question first are not ignored, but definitely there is a logical sequence of questions which we will take care of. We encourage you to basically post your thoughts on the chat section, interact with each other during the webinar conversation, and also give them the questions in the Q&A section that can really make us to tag out the questions separate from the normal chats. So let me introduce the PMI UAE chapter back once more, and that will launch us into the session today. Okay, so the Project Management Institute, PMI UAE chapter, is the part of the PMI. Of course, we all know that, which has been founded by the group of project managers in 1969. And now, even after 50 years, now it has been the source of knowledge and the most of the resources which we follow into the project management as a field. It is one of the largest associations in the world. It offers a lot of accreditation and communities on the trainings. Of course, we do a lot of global recognized standards and credentials has been formulated as a part of knowledge frameworks on the PMI. Specifically coming to the PMI UAE chapter now. So we have a vision of empowering and influence the individuals with innovative project economy, principles to turn ideas into their realities, followed by the mission statement to disrupt and create value-driven opportunities to our chapter members and the partners to become agile, innovative, productive in the platform for the growth of project economy. With that in mind, this is our chapter. It is 100% run by volunteers. As you can see, some glimpse around on the right-hand side. It has crossed 4,000 plus members, ranked among the top 5 chapters in EMA region. And then, of course, we are here to really help out the community as an aspiring frame of the things in the field of project and program professionals. We are dependent on the people like you who are there to make these project activities as invigorating as possible with all of us. Our board is led by Mr. Adil Sultan as the president, and rest of the board of directors who is helping him out from the different sections to run the governance and the other section of the board of the chapter. Membership benefits, which we are going to see, is that specifically associated with the chapter membership. Definitely the 2024, which we have already passed more than 6 months to 8 months now. So it consists of networking, knowledge sharing, career growth, and events. This diversified webinars is the part of event section. And my team as a part of event team is under these sections, which we do as a webinar plus the on-site sessions and other workshops as well, which we are going to do in the period of time. With our new initiatives, which we have come across in 2024 specifically, we have introduced Members Corner, Member Spotlight. These kind of opportunities gives a lot of empowerment to the members to share their ideas, to share their learnings, and also to focus and to showcase the whole overall opportunity and contribution to the field. If you want to get more information, definitely feel free to go and visit our social media websites, including the pmiua.org and the LinkedIn, YouTube, Instagram, and Facebook. If you have any particular queries regarding membership, there is already an email address which has been focused around there. And then related to general queries, you can put the email to info@pmi.ua.org. One specific nuggets I want to share with all of you regarding the PDUs, which is one of the component of these webinars, is that you're supposed to use the particular ID while registering these webinars. So there is a PMI ID and there's a PMP ID. So definitely what you need to be mindful about is to use your PMI ID, Project Management Institute ID, not the PMP certificate ID. If somebody is using the PMP ID to register it, they will be falling out on the PDUs. They will not be getting it done through. Just a quick reminder so that you people keep in that mind. So with that in mind, I would say that I would like to introduce our speaker today, Cathy Farina. She's the Vice President of Dicat Solution, as a company which provides innovative solutions to heavy industrial business sector. She has 25 years plus experience in oil and gas, petrochemicals, renewable energy, mining industry, and most recently, she has worked with global customers, providing her expertise and trainings with tools to implement the modularization, lean designing, and productization of their projects. Cathy also has played the role as a subject matter expert in execution of manufactured approach in heavy oil program delivery in Worley Parsons. Cathy is also has led internal initiative to develop and standardize design catalog for minimum kit modular well pad for both new and sustaining capital projects. So with that, I think the Cathy is all set to share her ideas, thought process with us on this particular webinar now. So Cathy, welcome on board, and then the floor is to you.
Okay, great. Okay, there we go. I'm going to share. Hopefully everyone can see okay.
Yes, you can make it full screen. That would be great.
Yes,
as well.
there we go. I'm just going to find my mouse here. There we go. Okay, hopefully everyone can see okay on that.
Yeah.
And thank you. Thank you very much for that introduction. That was great. And I want to thank the PMI UAE chapter also for inviting me to speak at this webinar. This is something I'm very passionate about. So hopefully this is a great webinar for everyone and you have lots of questions at the end. So today, so good evening, I guess it could be good morning and good afternoon, depending on where you are in the world. Today, we're going to talk about the innovative strategies to reduce costs and boost project efficiency. So we're going to dive into some strategies that I think will help. And it doesn't matter what industry, this is going to be really focused on the heavy industrial industry, but you can apply it for all different industries, but it'll help kind of think of ways to reduce the cost. So the current capital project performance has been kind of increasing and overrunning their budgets over the last decade, and they've been increasingly poor performance on these capital projects. This is just a survey that was done by senior project executives, and some of those projects have overrun their budgets and schedules by 30 to 45%, and it's trending to even be worse. So it's trending on even worse on the project cost overruns and also the schedule overruns. And so we have to think of ways other than what we're currently doing, other strategies to better the performance of projects, so they're at least coming in on budget and on schedule, or even reducing costs further. So this is another from the survey from these senior executives. They stated that we must, for the future performance, we must find a way to cut project costs and delivery times by 30 to 50%. And also with that, have that high confidence that projects will meet their budgets and schedule. And this is where those strategies have to come into play. We have to do something different. We have to think of our projects differently, and implementing some innovative strategies that can help with that reduction in cost and schedule will help with the future expectations that these senior leaders are expecting on their capital projects. So with saying that, I want to talk about 4 proven solution-driven strategies that have been started and kind of been implemented over the years with some proven results. And these strategies have proven to either reduce cost or reduce schedule or reduce cost and schedule together. So we're going to talk about these 4. The first one being implementing optimal modularization strategies. So I'll talk a little bit in the slides later about what that means. But these are really focused on reduced cost and schedule for capital projects. The other one being employing productization methods. And that is, looking at kind of the standardization of components or facilities. And I'll go into what that means here in the later slides. The third one being develop a minimum kit using lean design methods. And so this is removing design waste. It's looking at removing design waste from your overall facility or your project design. And then enhancing efficiency through lean-based execution strategies. Now, this is looking at your overall execution of your projects and how can you maximize the customer value by removing or eliminating some of that execution waste. So we're going to talk a little bit about collaboration in this one and some other strategies that you can look at employing or implementing on your projects. And these strategies have proven to reduce either cost or schedule by 10 to 35%. And it depends on how much you implement of these strategies. So when and how much you'll see with the cost savings and schedule savings. So I'm going to dive right in. I've got a lot to cover over this next a little bit. And we're going to talk about modularization strategies first. So this is one of the first things that I think most projects it doesn't matter what industry, but most projects should look at a modularization strategy. And what modularization really is, it's a strategy to move work off-site. So this is based on these pictures are based on heavy industrial, so based on a heavy industrial petrochemical facility. Or oil and gas, but you can think about this also in a way that how can you apply it to your current industry that you're working on. So when we say site construction, we're saying that that work is being done at the site location in the final installation location. So that's work being performed at that site location. When we're talking about modularization, we're talking about off-site construction. So we're talking about moving that work from that site location off-site into a more controlled environment. And that more controlled environment could be close to the site. It could be a location that's close to site, or it could be a location that's actually overseas, far away, and more of a manufacturing facility. So there's options there that you need to look at when you're looking at modularization. Now, the three terms that we use, and this is based on the latest research at the Construction Industry Institute that's actually located in Austin. These definitions are kind of what makes up modularization. So there's prefabrication, and prefabrication is really taking components and combining them together. So whether you're welding them together, essentially in this example, we'll be talking about welding these components together to create a more larger component. So for example, piping spools, where you're welding flanges, pipe, tees, fittings together to create that larger piping spool. Structural steel is welding, steel sections together to create a larger frame. So that's a prefabrication. Or else prefabricated pieces of equipment, like prefabricated vessels. The next one's pre-assembly. So this is another term that's used for the modularization. And that's really taking those prefabricated components and combining them together for a larger section. And those are examples of the utility stations or sample stations, stair towers that include lighting, or roof panels. So creating roof panels, so pre-assembled roof panels to go on top of buildings or houses. And then the module itself, when we say module, it's really saying that there's sections or pre-assembled sections that are combined within a structural frame. So that structural frame is the module itself. And there's a couple different options for these modules. You can have pre-assembled racks, which include electrical cable tray, electrical and instrumentation and controls cable tray, piping, all within the structural frame. You can also call them mechanical, electrical racks as well for buildings. There's also pre-assembled units or vendor package units, which are really equipment modules. So now you're adding in your equipment into those structural frames, as well as your piping, your electrical, your controls, and your instrumentation, all within that structural frame. Then there's pre-assembled buildings, which is really building modules, and they can be electrical houses, they can be control rooms. They could be even commercial buildings, so they could be apartment sections, buildings. There's also construction buildings that you can do as pre-assembled buildings as well. And the last one being dressed vessels, so dressed equipment. So basically having equipment dressed with all its auxiliaries, including piping, instrumentation, controls, and their ladders and platforms. So when we talk about modularization, I want to introduce a new term called percent modularization, because this is very important. This really looks at how much can you move off-site, how much labor can you move off-site, will determine how much percent modularization you have for your project. So we take the total construction hours moved off-site divided by the total construction hours for a traditional stick-built project. So a project that's completely done at site. So it's a key definition when we're talking about modularization, and a lot of people miss it and think it's the amount of materials we move off-site or onto modules. But it's not. When we're looking at percent modularization, think of labor. It's how much labor we're moving off site. And that's going to equal, in most cases, cost savings. So that's why it's very important. So looking at the benefits and why this is a strategy that you should look at implementing on your projects is because these are proven benefits from multiple modularization projects over the years. You can get a lower total installed cost, so lower capital costs. And that's because you're moving your work off-site into a more controlled environment, so you have improved labor productivity, okay? And in some cases, you're going to have an improved labor cost if you're moving your labor into off-site into, say, less cost center. So if you're moving it into a manufacturing facility that is lower cost than your site facility. You're going to have that improved labor productivity that leads into that lower total installed cost. You're also going to have an improved schedule, and the improved schedule key, and I'm going to talk about this in the next slide, is you'll see an improved schedule when you move work off site if you plan for it early in your project. Okay, if you plan for it early and you understand the differences between a modular project versus a traditional stick-built project, so a traditional way you would execute. There are differences, and there's differences on how you would execute a modular project. You're going to have that reduced project risk. We talked earlier about the need for having confidence in your costs, your budget for your project, and also your schedule for your project. Well, this provides more cost certainty and schedule certainty because you are in a more controlled environment, and they have certain processes and procedures in those manufacturing facilities or those module fabrication and assembly yards that use, and therefore you can provide a little bit more of that schedule and cost certainty. Plus, when these modules arrive at site, they are installed, and then there should be minimal work interconnects that will have to happen, which reduces that risk of an increased schedule because of things that are out of their control at the site. You've got your improved quality and safety performance because, again, you're moving it into a facility, an offsite facility that you can control a little bit more of that quality and control your, say, safety. You don't have to work at heights. You can you work more at the grade level. And then there's that improved sustainability, which is if you do an actual optimum modular layout and you look at your layout a little bit differently, you can reduce your overall carbon footprint because you're reducing your overall plot plan. So key quantities, the overall carbon footprint can be reduced. So when you're deciding to modularize, the key thing I want to make sure everyone understands, if this is something that you want to look at implementing on your projects, looking at moving work off site, you need to do it early. So you need to decide on this strategy early in the project life cycle. So if you're looking at the decision to modularize, we would recommend doing it in, say, the opportunity framing or FEL 0 when you're looking at the different projects that you want to implement on a business. So this is in the owner's court, so looking at if modularization is right for the project. This is when you want to decide to modularize, or at the latest FEL 1 or the assessment phase or pre-feed. So these are some of the probably terms, and if you're not used to these terms, you kind of think of phases. It's the earlier phases for your specific industry that you want to look at this. And the reason why is because as you see 1 through 9, I'm not going to go through them in this presentation specifically, but 1 through 9 are some key decision points that are required for a modularization project to make sure that you are adjusting your planning and your execution and your design for a modular project. So these are key decisions that have to be made. And you can see the first one being as early as possible. So that is for the modularization decision. Now, when you're looking at a modularization, a lot of people say, or a lot of projects have said, let's maximize the modularization on this project. So let's put in the maximum amount. But we don't think that you don't want to really look at it being maximum. Look at it being more optimum, because there is a sweet spot on every project based on project specific factors of how much is the optimum amount of modularization. And remember, when I said modularization, it includes prefabrication, pre-assembly, and modules. So you have to look at that earlier on, and it includes looking at your layout differently. So when you're looking right now, we have a lot of traditional stick-built layouts that are utilize a lot of space on a plot. And when we are looking at a modular project, we are looking at that plot plan or that plot layout a lot differently. We're going to look at it letting modularization drive the plot layout. So recently, actually, probably ever since modularization is starting to become more and more popular, especially in the heavy industrial industry, there is a lot of modularizing a stick build or traditional layout plot plan. And that isn't an optimum modularization strategy. You're not going to get your percentage modularization that you would like for that project, and you won't see all the benefits modularization can bring. So in the modularization one, you need to look at your plot area and plot plan differently, and therefore you let modularization drive your plot. You throw out that stick-built plot plan and you actually let the modularization strategy drive how you're going to lay out your plant. And there is a process for that you actually can, it's an optimum modular layout process that you can use to actually do that layout differently. So that is modularization as a high level introduction to it, but something that I think all projects, all capital projects really should be looking at now, because it is something that is starting to grow globally and helping that cost and schedule certainty. Now, the second thing I really want to talk about is employing productization methods. And we're going to talk a little bit about this because this is something that's starting to grow in the heavy industrial industry, but also has grown in the commercial and building industry as well. So productization, this is an overall global kind of term. It really can be defined as the process of analyzing a need, defining and combining suitable elements into a product-like object, which is standardized and repeatable throughout multiple, either within your facility, or you can have repeatable plants. So this is the productization has been used for lots of different areas. In the pharmaceutical, there's a lot of productization on how they productize some of their components. In the building industry, there's productization of different, like productization of, say, washrooms. So you're productizing that washroom element. because you're standardizing it, you're putting it in within a set of boundaries, and you're standardizing it to go in multiple, say, levels of a building, or even multiple buildings. So I'm going to talk a little bit about industrial productization, because the industrial productization is starting to become looked at more and more now. And this is more in the heavy industrial industry. So looking at, it's the process of designing and building, say, a process facility or an area or a unit in a process facility that can be replicated for the same type of facility. And I'm going to give you some examples. In an LNG plant, there's going to be LNG trains. So train 1, train 2, train 3. So for train 1, you can standardize that train and then replicate it for train 2 and train 3. So that's an example of kind of within a facility. And then you also, for actual overall facilities, for a gas plant, for example, you can standardize the gas plant and put it in multiple areas as well. So that's kind of a standardization of the gas plant itself. And then the other option is also, say, compressor facilities along a pipeline, compressor or pump stations as well. There's also well sites, so well facilities, so well pads or single well sites. Those are very open to be able to be standardized and ultimately productized. Another option that's becoming more and more popular is small scale facilities, small scale renewable gas, small scale hydrogen facilities, small scale nuclear plants, which are starting to become more and more, hopefully they'll start to become more and more popular here with some of the regulatory issues being resolved. Small scale LNG also is another example. So why productization, as far as what we would consider it for the heavy industrial industry, is really taking those modules I talked about. So what a module is, so a section or block from a facility. So that module, and then standardizing those modules. So you can standardize those specific building blocks for a plant. And the standardized designs, you'll have a design that has a process envelope around it. So whether it's the overall train or facility, or whether it's just a section of that facility or area, but it'll have a process design envelope that can be replicated on multiple areas. And it's engineered and authenticated once, but executed many times. And I'll give you an example of a well pad facility in the next slide, so you can get an idea of what we're talking about when we say productization. Another example on the picture here is a data center. So the data center itself is going to be a module. So it's a building module in this example, and it is got a standard design that's put into these building modules, and they're replicated multiple times. So that standard data center is replicated multiple times. And they may have some options. They may have a mirrored option. And so they have option 1 and option 2 that you can choose from depending on where you are at the site. And that is all included up front when you're looking at how you're going to productize your specific facility or section of your facility. So an example of a productization, a full facility productization was looking when this is a case study of a well pad facility for a SAGD. So it's for a steam assisted well program. And so these had multiple wells on them. And what we did is we actually developed a program of standard building blocks, essentially a catalog of standard modules. And these modules had a design envelope for the whole area that we were going to replicate. So we were putting in about 2 well pads a year, so 2 facilities a year. And so that was what this was based on, this envelope took into consideration location, process conditions, reservoir conditions, and that's how we standardized these building blocks. So we had a pipe rack standard module, we had an inlet standard module, we had a well pair standard module, an electrical building standard module, and a separator standard module. And that's how we put together the well pads. So these were standard modules that could be fabricated and assembled in advance with standard tagging. And then they would be allocated to the specific well pad at the time that they are required. So they were fabricated like manufacturing a car, for example. So they were manufactured like a car. So multiple pipe rack standard modules were manufactured as standard with standard tagging. And then you created that productization. So then when a well pad was required, you took the standard blocks and then developed your facility based on those standard blocks. So you could see in this specific 6 well pair facility that it needed 3 pipe rack modules, it needed 6 well pair modules, it needed an electrical building, an inlet standard module, and a separator module. So some of those key benefits that we see from from productizing, some of your facility, you can either do equipment within your facility, you can do full sections, so full areas of your facility, or you can do the full facility itself. And that you'll gain different types of benefits or different range of benefits depending on how much productization you have on your project. But you can get that cost and schedule certainty because after you perform the first one, you are very well aware of the cost and very well aware of the schedule and actually how you can improve cost and schedule as well after that first one. So you have your first one and then all the replication after that first one will provide that cost and schedule certainty. It reduces that program or project risk. So the productization, you really need a program. And your program can be part of your facility or it can be a program of projects that you're looking at. It reduces that risk because you are well aware of the cost, the schedule, and any after that first one you have lessons learned. So you implement those lessons learned. You do see reduced capital costs on the ones after the first one. You do see we've seen up to 20% reduced total installed cost based on repeatability. So because you're repeating the design, you know what the design is, you're able to do standard spool sheets, you're able to do standard construction drawings. Those are all reduction of capital costs. It also reduces your schedule as well. And we've seen the schedule be improved by 50%. So reduced by 50% on the repeatable facilities or repeatable piece of equipment. Your safety performance over higher quality, because again, you're using repeatable components. And then you've got your reduced life cycle costs because in operations and maintenance know what they're getting. They've got input into it. So they actually have a repeatable way they can operate and maintain the facility. And the last one being the focused value improvement program. This is where you put your lessons learned and you can actually put in some innovations into an actual program that will implement these on generations. So the next generation, like your phone, the next generation always gets an improvement. Similar to that with using productization on your facilities. The next generation will be even better. And again, just to talk to the timing, you really need to decide to productize early because you need to look at what you're productizing, so the program or what in your facility you're productizing, and then you need to design the envelope. There are some specific requirements that you need to do earlier on in your project to set up the execution design of these of what you're going to standardize or what you're going to productize. And that has to be done before you start diving into the overall design of the facility. So those parameters have to be set so that you can set up how you're going to design these productized items or the catalog, if you're going to look at it that way. So that's a little introduction to productization. It's pretty high level. There's a lot more detail that goes into it, but it's something that I think you should look at as an innovation strategy especially if you have any repeatable projects, any repeatable components in your project. So if you have repeatable, say, rooms within a building, this is a great way to not only look at standardizing those buildings, but also modularizing them and moving them off site. So looking at, if you're in oil and gas, do you have any standardized areas within your facility, or even if you're looking at well pads or well facilities, it's a great opportunity. And then anything small scale that's coming in here, like small scale nuclear, small scale hydrogen, small scale renewable or biogas plants, all great for productization. So the third strategy we want to talk about is developing a minimum kit using lean design methods. This is great for really looking at now the design and removing that design waste. Okay, so really removing the design waste and not having a gold-plated design. You're actually having more of an industrial standard design. So something that's more industry standard versus gold-plated. So these methods are the ones I'm going to talk about today, and these are ones that have been implemented on projects very successfully and have proven that it has reduced cost and schedule. So aligning with the class of plant with the business needs. So I'm going to talk about what class of plant means, and this is going to be focused on the industrial side again, but the same concept can be applied with multiple industries. So aligning that class of plant with the business needs, you got performing a life cycle cost analysis. And this is looking at the big picture versus very siloized little pictures, and I'll talk about that. And then optimizing standards and specifications. So over the years, we have gotten a lot of preferences included in standards and specifications, a lot of, I guess, more nice to haves being added into these standards and specifications. So they have grown in size, and that meaning growing in size, meaning growing in cost. So it's costing more to purchase items for the designs. So we're going to talk a little bit about that. So you've got your class of plant or class of facilities tool. This is basically a structured decision-making process. It's made to help establish and manage the engineering and design scope for a project. And it's really based on aligning it with the business case or the business drivers, the overall business case or drivers for the project. And what the intent of it is to actually have that alignment, but also improve that communication and understanding of the project goals. So a lot of times projects get put on saying that they're a go ahead and start the execution, start the design process. However, the end goal for the owner, that end business, why they're doing the project, isn't really understood. And therefore, a lot of times, say the cost or schedule does not meet what those business drivers are at the end. And therefore it doesn't go ahead. The project either gets delayed because they have to go back and reduce cost, or they have to go back and reduce schedule. So a lot of this is to do with like new plants, and this is really new facilities. And you're kind of looking at aligning it with those business drivers for that facility. Why are you putting that project in place? Like, why are we constructing it? Why are we designing and constructing this project? And then that will align with the optimum cost and schedule. So then that you are actually aligning with what that expectation is. For existing projects, this can be used as well. It's just you may have some limitations to what you can do in an existing facility. So this is an example of what the facility class. So when we're saying a plant class or a class of plant or class of facility, it depends on what class it is. So you can see on the chart here, you've got class 1, class 1.5, 2, 2.5, 3, and 3.5. And as you go up in class, you go up in cost. Okay. So the highest class means the highest cost of your plant. It's going to cost higher. It's going to cost more. So this is where that class of plant really comes into play on what is really the expectation of the business, of the owner, to what they're asking for. So basically, if they are looking for a top-notch gold-plated plant, you know, that has all the bells and whistles, then they're going to be more in a class 3, class 3.5. If they're looking at more of a industry standard minimum requirements plant, for various reasons, they're going to be looking at more of 1.5. So that's kind of the difference between the range. You're going to have to do the business case alignment, which I'll talk about in the executions section here. So that business case alignment is really looking at what those business drivers and what that business case for the project is. And that's what should be aligned with the class of plant. So what we do is we look at some performance categories for the plant and for the facility. And we're looking at, say, these are the categories that are part of the overall tool that when you go through and you develop a class of plant, these are what you're going to be looking at: capacity, expandability, reliability, flexibility, operational and maintainable, and the controls philosophy. So these are specific questions that will be asked, and then there's specific classes that you will choose from: class 1, class 2, and class 3. So this is done as a workshop with all the stakeholders from the business side as well as the project side. So that's key. Both stakeholders within the owner operations need to be there to perform this class of plant. And I've got an example of one that's been used. So this is an example of a class of plant kind of tool that could be used. And as you can see, there's an item. This is really focused on design, remember. So there's a design item. And then from that design item, you've got what class that you would choose from. So whether it's going to be just minimum requirements, industry standard on class 1, or whether it's going to be with all the bells and whistles, with a lot of you know, customization on class 3. Okay, so that's kind of, the class 2 is kind of in the middle of that. So it's not quite industry standard, but it definitely doesn't have all the bells and whistles as class 3 does. And then you've got a cost impact. So you understand what that cost impact is. So some of it's high, there's medium, and there's low. So if it's a high impact, then you can just kind of determine more about what that you know, class should be for that specific item. If it's a lower impact, you might maybe choose a higher class depending on what that item is. So this is just an example from the process control worksheet. 3 of the 3 items. This is a detailed worksheet that goes through multiple items on this. And then after this is complete, you'll get an average class of facility. And then that's where your design basis starts from. So all this feeds into your overall design basis for your project or facility. Then you've got the life cycle cost analysis. So this is important because a lot of times projects are very siloized. So a lot of disciplines work just very on their own. And so when they make a change or make an optimization on a project, they may go, okay, well, I'm going to make this change because it reduces my overall discipline cost. So for example, if it's a heat exchanger and it's mechanical that's looking at it, and they're saying, well, if I make this change to this heat exchanger with the vendor, they'll reduce my cost of that by 10%. But what the issue is by optimizing that heat exchanger for, say, for a modular project, a project that is using modules, that if you increase that heat exchanger, say by reducing the cost, but you increase the length of that heat exchanger, and it no longer fits on the module, it now has to be moved off the module, and it is now going to be site constructed. And then for the operations and maintenance, you may need to add platforms in there. You may need to add stairs going up to it. So actually, in the grand scheme of the overall picture, even though mechanical, that discipline's reducing the cost, the overall picture of the project, you're actually increasing that cost, that life cycle cost by maybe 10%. So you have to look at the overall picture. So when we talk about the life cycle cost analysis, we're talking about it being employed throughout the whole entire project. So when you're making decisions and when you're making changes, you're collaborative with everyone, all the stakeholders, and you're looking at the big picture, the overall life cycle cost of the project itself. So there's a method that you can use to calculate the total cost of an asset throughout its life. And then you can look at the individual components of that facility and the changes that how it impacts that overall life cycle cost. And usually when you're looking at the life cycle cost, you're looking at it as internal rate of return or net present value. But it looks at that financial health. It's all obviously the overall financial health of that project. The other component could be extending a project because you do a change and it extends the project schedule. And if there's a time to market business driver, it needs to get on by a certain time to get to market. You could be actually really impacting that overall life cycle cost. And then optimizing standards and specifications. Over the years, over the many years, we started out with specifications, decades ago that were usually industry minimum requirements, industry specific, but over the years, there's been preferences added, there's been gold plating added, there's been a lot of, nice to haves added to these specifications. And so they're becoming more and more expensive, more and more gold plated. And that's where looking at optimizing your standards and specifications to align with your class of plant, it would be really good to reduce cost. So for example, a lot of times specifications and standards come into play and you have to purchase a customized product or material, piece of say a valve or a control valve or an instrument. And that by purchasing that customized, it increases the schedule and cost. If you could go to a minimum requirement and use what's available out there, so use what's part of the vendor's standard, you would reduce the cost because not only will they have it available, you'll be able to get it quicker. So it'll be less costly and you'll be able to get it quicker, and you may not impact the schedule itself. So reviewing the needs versus the wants will actually maximize that owner's value. So you're going to be reducing your overall costs, potentially reducing your overall schedule, and with reducing that design waste. So going on to the last strategy section is going to be enhancing efficiency through lean-based execution strategies. So now we focused on the design, we focused on the overall project with modularization, with productization, the design with the lean design. Now let's look at execution. So lean execution. And there's a lot of lean execution strategies out there. Right now, we're going to really focus on some different ones that maybe you haven't heard about. So I'm going to talk about today the business case alignment. And the reason why business case alignment is so important is because I've talked earlier about aligning those business drivers or that business case with the overall project design and also project goals. So what is their target cost? There's a lot of things that are miscommunicated to a project team, and therefore for them to be successful, if they get the business case alignment and they understand really what truly the business drivers are, the success of the project meeting those business drivers is going to be increased. Advanced work planning, I am going to talk about advanced work planning or advanced work packaging, AWP. I'm not sure how many people have heard about it, but we will talk a little bit about that because that's something that is very strategic in the execution to help really meet that cost and schedule objectives. So we'll talk about why. And then integrated project delivery, so contracting strategy. And we'll talk, that's starting to become more and more popular among all industries. We'll talk a little bit about what that is. And then the last, collaborative project execution. And this is super important because this is where I think we need to get back to the removing the silos. So business case alignment. It's a process that's based on establishing that clear business case from the business side. And that helps with developing the design of the facility or group of facilities. So it really aligns the business side of things with the project side. And so you can use the same type of questionnaire with really specific questions around the project. And it's really around the business questions. So why are we doing this project? What are those business drivers? What's the target cost and schedule? So it's a really good way to get that alignment between the business and project and be more successful on your target. The second one is really around advanced work planning. And this is really taking your project framework, and it doesn't matter what industry you're in, but taking your project framework and dividing that project scope into manageable portions. And this is to do with work planning and execution. So this is taking that upfront blue circle you see and doing your plan based on those divided project scope. So you'll have a path of construction, a module sequencing, if you're using modules that align with your commissioning and startup. And that is what's going to drive your plan for your project. So then you'll align all your engineering, you'll align all your procurements or your supply chain with the priorities for the project right up front. So that's how it drives your schedule, and it drives your overall execution plan as well. And this has been proven to improve productivity and predictability of your project, and really that certainty around cost and schedule. The third one being integrated project delivery. This is around bringing your stakeholders in. So bringing your contractors in and all of your stakeholders in earlier. So this is where you actually are more collaborative with your contractors. So the owner and, for the example here, your designer and your contractor are brought in together earlier on to develop the overall plan, the overall execution plan. And it's a risk sharing model. So everyone shares the risk in the project. So it's not like what we're currently doing in a lot of projects is the owners transferring that risk to the contractors. And therefore there's a lack of trust and transparency because that risk is being held by those contractors. With the risk sharing model, which is the integrated project delivery model, you actually share that risk and that trust increases, and as well as the collaboration, the integration, and that communication. So you align the stakeholders with the goals of the project objectives, the business drivers, and then you look at what would add value to the project within those contractors. So they'll come up with innovative ways to save costs and save schedule. Last one being collaborative project execution. We're currently working so much in silos. So on the left-hand side, you'll see that vertically organized project where all the disciplines have a discipline lead, and then all those disciplines report up to that discipline lead. That discipline lead then reports into the engineering manager. But it's very, everyone's working kind of in that siloized, hierarchical based. It's very individual based. What we recommend is really, and this is all projects, looking at collaborative project management, you actually look at moving your organization to more of a horizontal or organized project. And that's looking at moving your team from that vertical dimension to more horizontal. So if you're working on a section of a plant or a facility, you have maybe an area lead for that facility, that area, that section. And everyone's working together for that specific goal. So all the disciplines are working together horizontally, it's team-based, and to the end goal of what their specific area's goal is. So you have a goal at the end and you're working horizontally with everyone on that goal. It really enables that collaboration, that open communication, and it has greater trust and transparency. This is where we believe all projects should be moving. And it just increases your project success because you have a really open communication, and everyone can provide their innovative solutions to any challenges that come up. So in conclusion, that I went through a lot of that very fast, a very high level of what those innovative strategies are. And I've just chosen a couple of them out of a lot more strategies that can be used on projects. But in conclusion, these are the 4 that I think if you start to look at and start to see how you can implement some of these on your projects, you will start to look at how you can reduce that cost that we need to reduce for future expectations, and how you can actually reduce that schedule as well, and improve, of course, the cost and schedule certainty, which we're lacking right now because most projects are going over budget and they're also going over schedule. So I believe, I'm not sure if I'm right on time, but I'm hoping everyone learned a little bit. I went through it fairly quickly, but I would like to open it up for questions and start to talk and see if anyone has questions around the content I did talk about today.
Thank you, Cathy. I think you are right on the money. Exactly 8:31 for over there. So definitely your time management was 100% correct there. So congratulations for that. Of course, we are looking for the questions. So we have one questions. I see one question so far. And the question is speaking about your advanced work planning, what you just explaining around, right? So in the form of scheduling. So how is it different or similar to the work breakdown structure, which is one of the project principle which we learn in project management, right? So that's what the question from Mr. Asid.
Yeah. So the work breakdown structure is what the advanced work planning does is it aligns the work breakdown structure. So what you do is you look at how you're going to split up your plant up front. So you have construction work areas, and then you have construction work packages from that, or module packages, depending on if you have a modular project. And so what your work breakdown structure does is aligns to that breakdown of that construction work area and that construction work package. And that's how you can cost as well as schedule and plan your project. So is it the same thing as a work breakdown? No, it's a way that you can actually break up your work more effectively using construction up front, so construction driven, to align your work breakdown structure to that, if that makes sense. So similar in the way that you align, it's more alignment of the work breakdown structure.
Okay.
Hopefully that answers the question. It's really
yeah. So at least there is a subtle difference, but the alignment is there in the form of the timing, the alignment in the risk. That's how they are different a bit, but they are leaning towards a similar kind of thing, that how you define a work breakdown structure, plus how do you really manage that out with the theory what you're explaining. Now the thing is that it's a bit of more abstract concept, because in construction industry, most of the things goes in the form of something what you can really go and do the materialize and tangible aspect. But something like what we learn is quite different from the past. I would definitely honestly will say that I was not aware about these concepts. Even the construction industry background, these concepts are getting applied, but the innovation, what we're speaking about, the lean designing, was quite mind-blowing to me actually as well. One question Mr. Hassan is asking is that how procurement plan helps in optimizing your cost planning, cost optimization aspect about of these projects in the capex. How does that can come into that?
Absolutely. So your procurement plan, when you're looking at it, so in your cost optimization, there's a couple different ways that you can look at. If you, depending on what strategy you're looking at, but your procurement plan itself, sourcing is going to be key. Your sourcing of where you're sourcing your material. And if you're using modularization, you need to make sure you're sourcing close to the facility that you're going to be offsite fabricating and assembling at. But as far as the actual purchasing and cost of procurement, the key thing starts with engineering. And I was talking about that kind of optimizing the standards and specifications. If you are purchasing a customized product that needs to be customized by the vendor, and you have to put in a lot of input, there's a lot of approvals, it goes back and forth. That is going to cost a lot more than just using an industry solution. So the vendor has obviously a standard solution that they've developed for a specific product, whether it's a equipment like a compressor, a pump, or even an instrument like a valve or a flow meter. any of those that are standard and you don't have to customize, you're going to reduce the cost significantly because they will provide, there's limited back and forth because you're buying a standard kind of product. And two, you're going to reduce that lead time. So that lead time to get that product, which could reduce your schedule. Sometimes, a lot of times lead times of material will drive a schedule as well. So that's kind of another, and then another opportunity is framework agreements, which we didn't really talk about here, but looking at relationships and building those relationships with your suppliers earlier on. It's a little bit about that integrated project delivery where you build those relationships in, and those suppliers come in earlier and help select kind of the most cost-effective products. That's another option as well. So some different options with procurement. It also depends on what solution. If you're using productization and standardizing your engineering and design, that also leads into procurement savings as well. Hopefully that answered a little bit of that question.
Thank you, Cathy. Mr. Ahmed is asking that, would you share some of the references for the same subject? Not quite clear what kind of references he meant to. Of course, you were going to share the presentation, what you just showed us as an aftermath of the session, but any references around that?
So references, if you're including where some of the materials coming from, I could provide that if you could, I don't know if you're able to send it out to everyone, I could provide that separately. Just kind of, there's a couple different areas where, we've pulled some of the material. Some of it is from what we do at DieCats, but some of it I can pull those references together too. So I can pull out with some of the definitely the references where the material was being pulled. I'll send that to you if that's okay, and then you can send it out.
Yes, that would help. So you can add one more slide, the references there.
I just wanted to touch base just on that AWP, the advanced work planning, just another thing I thought of after I answered that. But the one thing about the advanced work planning that's different with the WBS is that you have that path of construction that construction brings in. So they actually provide a sequence of how things are going to be constructed within those work package breakouts. And that's as early as in the, when you're in the say pre-feed. And that's what drives your WBS tagging, that how you tag your WBS will align with how you're packaging. And that's how you're going to drive your schedule. So I just wanted to say that it's really construction driven, and that's really the point of it, advanced work planning.
Understood. Thanks for clarifying on that particular point. That would really help the audience to really discriminate between the two aspects around how the construction alignment need to come into the play there in the form of sequencing of the particular phenomena of the pattern, what you need to go first, and then based on that, what dependency you have for the second in that way. I think that's really great, Cathy. Thank you so much for your lovely inputs and then clarifying the audience question around that. Of course, you have shared your contact as well. Okay, just now one question. I think I should take this last one, but how the lean manufacturing concept in pipeline projects and how the schedule optimization. I think it's not a full question around that. What I can take it with how actually the lean manufacturing comes into this kind of pipelining project in terms of schedule optimization.
Yeah. So that depending on what, like, if for the pipeline projects, if you have, say, specific compressor stations or pump stations along that pipeline, you can definitely do those offsite. So those are kind of some like offsite type products that can be then in parallel. You can be doing your pipeline, laying your pipeline while you're getting these compressor stations or pump stations manufactured. You can also look at the productization side of things. Is there a way that you can productize those types of compressor stations and pump stations along the pipeline? So that can also improve the schedule. If you can standardize some of those items, you can actually then kind of produce them like a manufacturing process approach. So those are kind of those opportunities for the pipeline.
Great. I think that was the last one, Cathy, for us so far. But I think that was a really great session for especially to the people from construction background. They get a good nuggets in terms of understanding these theories and putting them into the implementation. Today, we are going to close the webinar with that last question in that mind. But of course, we will be sharing the presentation, which Cathy will be sharing with us. Of course, I shared the email address. If you want to get in touch with us, Joyce has also pasted that into the chat. info@uae.pmi.org is the email address which you can get in touch with us. With that in mind, definitely we are going to close the webinar without saying the big thanks to the people who attended this out for your lovely participation in the questions. I would like to give a shout out to the friends in the marketing team who was responsible for posting all the right relevant information on the social media and the event page in the PMI UAE website. We would not say goodnight without saying thank you to the rest of the PMI chapter volunteers who are always giving the big hand toward the successful webinars, and our colleagues from membership, outreach, volunteering, and finance and governance part as well. So until our next webinar, I think today is the time now to say the goodbye. And then with my colleagues behind, Amir and the rest of the event team, this is Anshul wishing you a pleasant evening ahead. God bless and stay safe. Thank you so much, Cathy. And thank you so much, the lovely audience.
Thank you, everyone.
Thank you. Good night.